know that 4 can be expressed with a base of 2. And what is that? 2 to what exponent? 2, right? 2 squared. And if you ever want to double check, just 2 squared, there's my 4. So I can re-express the 4 as 2 squared. 2 squared. And so because your bases are the same, this is solving exponential equations. When your bases are, oh, don't pay attention to that, 7. Now you can make an equation of your exponents. So that's where it says here, if you have the same base, then the exponents are equal. If you don't show that the bases are the same, you cannot make that mathematical leap. At least for the test, okay? All right, and so it's a one-step equation, and so -4. Yeah? Okay, for number 2, I'm still recording, by the way. Okay, for number 2, 16 is not a multiple of 8. 16 is a multiple of 4, but 8 is not a multiple of 4. So even though you're looking at 2 separate bases, they really want the base to be what value? Huh? Who said it? Or say it again? 2, right? So 2 to the 16, grab a calculator. That's 8. 16. So how many 2's? 4, right? So this is 2 to the 4th, the 3x, right? It's up to you. Some of you just right away multiply it and give me 2 to the 12x, but we'll write it like this. And then 8 is, whoops, not 22. 8 is 2 to the 3rd. So 2 to the 3rd x plus 6. And you just have to make sure you, distributive property here, that you distribute here. Okay, so what's 4 times 3x? 12x. And then this is 2, and then this is 3x plus 18. And now that your bases are equal, or they're the same base, now your exponents are equal. And now you can write, and you can solve for x. Keep going? Yeah? Okay, so minus 3x, I wrote too big. 9x equal 18, sorry. And so you get 2. I wasted too much space up here. Which of the fractions do you want? 5, 6, 7, or 9? I know some of you moved ahead. Like 6? Does that look harder? Which one? 5, 6, 7, or 9? All right, let's do 6. All right, 32. Okay, you got 64. So 64 is by 8, but I can't get 32 to be 8, right? Okay, if I go to 4, can I get 4 to be... Nope. See how it jumped? It went from 16 to 64. So far 4 is out, 8 is out. You're only looking at 2 at this point. There's 32. How many 2's? 5? 1, 2, 3, 4. Yeah? Okay, what about 64? Just go one more. And there's my 64. So again, if they're not, if you don't, you have to go through your numbers to see which one is both, can both satisfy the 32 and the 64. So, okay, 32 was 5 2's, right? Okay, but 32 is a denominator, right? So if you want to verify it on the calculator, type in -5, and you get 1 over 32, right? Or am I here? So 1 over 32 is the equivalent to 2 over negative 5, because really 1 over 32 is 5 2's, right, in the denominator's position. So if I bring it up, 2 to the negative 5th, 2x, and then 64, oops, sorry, is 2 to the 6 is 64, right? So this can be expressed as 2 to the 6. And so now that my bases are both 2, I can now create an equation of my exponents. Oh wait, let me just do this one step. Negative 10x, 6. Okay, now we go. And it's okay if you get right. Okay, I'll stop the video. Yeah. So what I would recommend is